All right, so let's take a look at the next couple of. Okay, so this says it's a 3 kilogram cannonball. It's shot out of a cannon with an initial velocity of 300 at an angle of 25. A headwind exerts a constant 5 Newton horizontal force. How far will the cannonball travel before horizontally hitting the ground? And then, of course, he gives you the solution. But let me go ahead and get the picture first. Okay, most everything is in that picture. Let me go back and make sure if there's any more information. The 5 kilogram is shown here, 300 at 25. Okay, so everything is in that picture. We'll just go ahead and add another page. So let's drop the picture. I have no idea why. I don't know. Just snip the picture again, I guess. Go immediately there. And for some reason it did that. I don't know. Well, first of all, there is nothing that happens to the y. Okay. If you want to look at it, um, uh, it's all fine. Whoops. Oops. Okay. So, if you do a free body diagram on the ball, you get the weight is equal to mg, and there isn't anything else pushing. There's no updraft or downdraft on it, so there's nothing there. So what you get on the left side of this is the weight is equal to mass times acceleration in the y. So the turns out that's the case. Mg is equal to m times acceleration in the y. So you get that. It's pretty boring. Nothing really fancy. And then what you do is you say, well, I have the acceleration in the y. You say to yourself, well, if I go back to the constant equations, let's just write them as s. Velocity t plus the constant acceleration, I'll put the ac there, t squared over 2. Now that was a single one. In other words, didn't have a coordinate. I can just replace s with y equal to y naught plus vy naught. That should probably be a naught. T plus acceleration of c in the y, t squared 2. What you find out is this, according to this, oh, and I should do this. Okay, let me make sure I do this correctly. That's positive. Therefore, the weight goes down, and you get that. You get a minus sign there. So you get y is equal to y naught plus vy naught t minus g t squared over 2. If you look back in chapter 12, that's the equation you have. Now let's do x. Before, if there wasn't a 5 Newton force, it's pretty boring. Some of the forces in the x going to the right, mass times acceleration of the x. If there was no force over here, then you just get ax equaling to 0. And therefore you got that set of equations. Now, this is a simple case where it's not that, it's minus 5. I don't know okay, I'm going to have to go back, find out the mass of this thing. Oh, 3 kilogram, okay. It was a 3 kilogram ball, so AX equal to minus 5 over 3. Now, here's what you get. Okay, that's your AX. If you come in here and replace S with X, you get X equals to X naught plus Vx naught t plus acceleration in the X constant t squared over 2. Okay, so this one yields that one for the X. It yields this one for the Y. Now you've got a situation where you do have an acceleration or some type of force. You're slowing the cannonball down in the X direction. So therefore, this becomes X is equal to X naught plus Vx naught t, this time minus 5 halves t squared over 2. So with this one and with this one together, and recognizing that, okay, I don't know why this is not, and recognizing in addition that if you had this shooting at 300 meters per second at 25 degrees, then Vx naught 300 cosine 25, Vy naught 300 sine of 25. That here, this there. Now the second thing, the last thing that you need to be aware of is, one, he doesn't tell us this, but I'm going to assume he doesn't say that this is so many feet off the ground. So I'm going to assume the range of this thing, the answer he's looking for is here and not here. Because I do not know whether this is 10 feet, or sorry, meters, 100 meters, 1,000 meters, 10,000 meters high. So I'm going to assume that this is 0 here. This means, put my coordinate system here, X, put my coordinate system Y. That means X naught is equal to Y naught equal to 0. From those pieces of information, you should be able to figure the rest of this out. Again, there really isn't an adjustment to the Y equation for parabolic motion. But it's truly not parabolic motion anymore because the X equation is not linear. Before, what you would see is this term right here, or here, this term right here would not exist. Now it does exist. So I think he wants to know, you have to go in, you have to use this equation right here, determine the amount of time that it takes for the cannonball to go up and come back down, use that time. There are other ways to do this. To go back, put in here, and that tells you how far it went. Fairly simple problem, but conceptually, unless you get over that big bump, it can be difficult. I have no idea why that showed up. Maybe I pushed something. Okay. Next problem. Maybe I should take a break in between. Yeah, no, I think I'll go ahead and do this one. This one is in energy. Okay. The incline transports passengers up a 30 whatever degree slope. If a fully loaded car has a mass of that, what power is required to maintain an uphill speed of that? Okay, so we're going to have to change. Maybe I should break this because this is a totally different chapter. This and this go together. I may break each one into a video. So I'm going to stop this and break this into a video, come back to this one. The video itself was 11 minutes already. That's good enough.